Greetings, I'm Yvonne, Staff for Science for the Public, and I welcome you to Contemporary Science Issues and Innovations. Today, we take up an especially important issue, the issue of toxins that are called endocrine disruptors and how they affect brain development. Our guest is Thomas Zoeller, Emeritus Professor of Biology and Director of the Laboratory for Molecular Cellular Developmental Endocrinology at the University of Massachusetts-Amherst. Dr. Zoeller is a widely Dr. Zoeller is a widely recognized expert on how these toxins interfere with hormones that, like thyroid, that are crucial to the development of the brain. This is especially important information in view of the weak regulatory policies of the current EPA and past also. Dr. Zoeller will explain what these products are, how endocrine disruptors do what they do, how they compromise development, how scientists like him investigate these hormonal disruptions, say the disruption of thyroid, how regulatory agencies investigate, and that's some interesting information. We are very honored to welcome Dr. Thomas Zoeller. Welcome, sir.
Thank you. Thank you for inviting me.
Okay, and I would like to start with a comment that you made that has great importance. You have said every baby in the United States is born pre-polluted. They have more than 100 toxins in their bloodstreams as they get started in life. What are these products, specifically the ones that are endocrine disruptors, please?
So the first thing is that I'm not the first person to say that.
I understand.
Yeah. Other people have done actually very good studies to show that every baby born in this country is contaminated with a large number of industrial chemicals.
Yes.
Now, the difficulty here is there are some of these chemicals that we know for certain affect brain development, like lead, like mercury, like perchlorate, like bisphenol A. We know that a certain number of these chemicals are, but many of the chemicals that we're being exposed to, we have no safety information at all about. And so, you know, this winds up being, I think, an incredibly critical issue because pregnant women and women with infants and young children really aren't seeing, and they trust the FDA and the EPA to make sure that chemicals are safe, but there's really, there's not that kind of protective umbrella that we should trust.
Right. Could you give us an idea of what the products themselves are? What name some of these? They are ubiquitous. I know that much, but what are the endocrine disruptors themselves, and then what products do we find them in?
Sure. So it's complicated, first of all, because the chemicals that interfere with hormone systems are really a wide variety of chemicals. And so they're found in a wide variety of places, from lead in paint to, you know, mercury contamination in food products to, you know, plastics and plastic food packaging. There are phthalates that are often used in personal care products so if you have a personal care product with a fragrance, chances are good it also has these phthalates. You know, there are parabens that are in sunscreen.
Seats.
Yeah, well, that's right. So they wind up being in places that are not always predictable. We did a study, in fact, we haven't published it yet, where human placenta in an epidemiological study has a kind of large contamination with pentachlorophenol. Now, this chemical is used to treat wood to make it
Oh, yes.
longer. And that wood is used in the stanchions that dairy farms construct so that they can milk their cows. While the cows are standing there, they lick the wood, become contaminated with PCP, and then people take it on through the milk.
Right.
So that's a good example of how it's not always predictable how
Yes.
we're being contaminated with a chemical that, in the case of PCP, can actually bind to the thyroid hormone receptor and activate it. So this is going to be a big challenge to get rid of these kind of activities, but we're not going to be able to do it if there's no political will.
Right. I want to come back to that on
Yes.
large scale in just a minute. Just one more thing to get with these. I know these things are ubiquitous and people are not always aware, but I wanted to mention linings of cans. They're in so many places, you cannot avoid it. And as you kind of implied there, you don't have to get a direct injection. They're everywhere. You're absorbing them through indirectly through these different products that we use all the time. Okay, so then I'd like to ask you, how does this work? Like, in other words, so these cross the placenta, a lot of these chemicals cross the placenta, and so you have this developmental period in the womb, and there's where so much of your work is instructive. How do these things, some of these things, interfere with thyroid? Why is thyroid hormone also so important? How does this work?
So first of all, thyroid hormone is essential for normal development. And in fact, every baby born in this country and all kind of modern economies, every baby born is evaluated for thyroid function at birth. And so there's a screening program that first began in Canada, in Montreal, and then I think Massachusetts, in fact, was the first to adopt this kind of screening program so that every newborn has a blood spot that's evaluated for thyroid hormone. And if thyroid hormone levels are low, then that's an emergency. Those children need to be identified and treated immediately within a couple weeks, or brain development is affected. Now, before this screening program occurred, the average time to diagnosis was something like 6 months. And at that time, the IQ, the result of that was about an IQ of 80. So this is really very important.
Exactly.
So the thing is
that, yeah, I don't think that we're that aware of how important thyroid is, and your work has emphasized that. So what you're saying, I didn't realize there is a test for this. It's so important. But what do these disruptors, what do these chemicals do that compromise the thyroid hormone in the development?
Sure. So there's probably several different pathways that very different kinds of chemicals can approach to interfere with thyroid hormone action. One of the most common mechanisms is a chemical like PCBs or polychlorinated biphenyls. There are many others like this that activate the liver and cause the liver to clear thyroid hormone from the blood of the mother. And so we now know, in fact, that the fetus doesn't really develop a thyroid gland until the second trimester. But thyroid hormone is critical during the first trimester. The only source of that thyroid hormone is the mother. If thyroid hormone levels in the mother decline, then the baby is left without thyroid hormone. And if that's transient, you won't know it, because at the time of birth, thyroid hormone levels in the baby will be normal, but the timing of the insult is past. So we need to be very cognizant of this. And some studies have demonstrated that maternal thyroid hormone levels that are low during the first trimester are linked to IQ in the offspring, to a lower IQ. And this is, we're talking about populations here. We're
not a kid here or there.
Yeah, so this is, it's incredibly important, and it's important for our society. It's important for mothers and parents, children, but also when we're talking about an IQ deficit in the society, that's really,
right.
That's a start.
Not that, but at this, internationally, at the human at this point. Dr. Zoeller, how much is toxic? I think that's one of your most important points, and we'll come back to it because we want to talk about the work that you have done specifically. But you mentioned how much is actually toxic before. That I think that you have said actually it's very, very small. The amount that is toxic is much below the standards given by regulatory agencies.
Right. So this kind of goes, this issue of how much is too much. Is a very, it's a tricky issue, because we have this concept that poisons produce some kind of linear response. So if I take a little bit of a poison, it's not going to hurt me. If I take a whole lot, I'm dead. And somewhere in between there is where we normally find ourselves. Hormones don't work like that. And in fact, the medical community has designed hormone mimickers that produce an effect at a low dose that's very different from the effect at a high dose. This is seen, for example, in breast cancer therapy. So tamoxifen is a drug that blocks the estrogen receptor. So one of the problems with it is that at a low dose, tamoxifen stimulates the estrogen receptor, and at a high dose, it reduces its function. So in breast cancer treatment, there's commonly called a flare, where you get kind of a flare of even tumor growth and pain that's associated with it. That actually means that tamoxifen is working for those breast cancers that are ER positive. Also, there's a drug called Lupron that's used to stimulate reproduction, but at a high dose, it blocks reproduction. This is actually used in two different ways. Tamoxifen at a low dose is used as a fertility enhancer in women. At a high dose, it's used to block some of the problems associated with prostate cancer. So this kind of, this upside down U-shaped curve is common in endocrinology. And so chemicals that can mimic hormones have this kind of inverted U-shaped. And so a good example is bisphenol A, where at a very high, this is BPA, at a high dose, it inhibits some measures of estrogen action. But what we and others have shown is that at low doses, it has effects on the brain.
Yes, and infant development, I think there's a lot of concern about bisphenol A, BPA, and that's one of those things that the industry kept brushing off for a long while. But I want to go back to this in terms of the development of the infant brain and stuff. That you don't need high doses, I think, is the point that you made. Is that right? I want to make that clear.
That's correct.
Need to take gallons of the stuff. That's one thing. And then there's another thing, is the effect well, before I get to that, I should say, what are the effects on the brain? I mean, so you've mentioned low IQ. Are there other things like ADHD, other kinds of effects? We're seeing record cases of like autism and ADHD, and I think this is a little more than genetics. Can you help us out there?
Well, so I think that when you think about brain development, it's kind of like building a house.
Yeah.
If you build the foundation at the beginning, and if you close that off before you put plumbing in or electricity in, you've lost your opportunity.
Yeah.
And that's the way the brain is assembled. From a very few number of cells, it expands and it goes through a number of stages. So depending on the kind of chemical that kids are exposed to, that the fetus and neonate is exposed to,
Right.
and the timing of that exposure, you see different kinds of things. And certainly, you're right that about almost 20% of children today are diagnosed with some kind of neurodevelopmental disorder. That's an
Wow.
enormous
That's
consequence.
incredible.
Yeah.
And
And
recent times.
so there's good evidence that environmental chemicals are affecting or increasing or contributing to the epidemic of autism, of ADHD. It's clear from some clinical studies that thyroid hormone, that interference with thyroid hormone can increase ADHD, diagnoses.
I see.
So it's not just IQ, but it's a number of
Right.
both physical and mental
Right.
kinds of domains that are being affected.
Exactly. And I want to come back to that again with the industry denial on this as well. I would like, though, now to go to how you actually study these things. For a couple of things. Do you look at human development as opposed to rat development? I think the other is because one of the industry things excuses is, well, they're looking at rats, but that's not the case. The other is, it is my understanding that you need long-term investigations. You can't do like 9 months of fetal development and drop it. You need years really to evaluate the effects development changes over time. So I would like to include that in how you do your studies. That this is stuff we don't hear a lot about. If you would, please.
So the first thing is, so I trained as an experimental endocrinologist. That was my training, and I was working in the 1990s to determine, first of all, whether thyroid hormone crosses the placenta to the fetus. At the time, the dogma clinically was that thyroid hormone does not cross the placenta. And so if a woman had thyroid disorders, it really wasn't, people didn't worry about that. So that was one of the key questions that we were trying to answer. And the second was, if thyroid hormone from the mother gets to the fetus, what is it doing? Is it actually having direct effects on the brain? And so we're using kind of what are now, that's 15 years ago, actually 25 years ago, seems like primitive genomics. So we're looking at the ability of thyroid hormone from the mother to regulate the expression of genes in the fetal cortex before the fetus could make thyroid hormone itself. So the first paper we published in the late 1990s was really addressing that issue. Now, we were using rats because you can't do that in a human population. But what that kind of in the mid 1990s, I was also on, it was called the Endocrine Disruptors Screening and Testing Advisory Committee, that was assembled by the EPA, required by Congress to develop an endocrine disruptor screening program. that's the first time that I became aware of the way industry and government was thinking about how to evaluate a chemical for its ability to interfere with the thyroid system. So, I was trained and accustomed to thinking of thyroid hormone action by looking at the tissue that thyroid hormone affects. What the government and what industry did at that time, and still to this day, still only looks at thyroid hormone levels in the blood. And so what does that mean? That's kind of like looking at traffic on the highway and making some estimate about how many people live in that place.
Yes, gotcha.
So our very first experiment was very simple in principle. If we expose pregnant animals to PCBs and thyroid hormone levels go down, which we knew it would because it had been demonstrated by many different investigators at that time, what would happen in the brain? Because we'd been studying the brain, we knew what should happen. And I expected to see a relationship between serum thyroid hormone and genes in the brain and developmental events in the brain that were affected in concert with that reduction. And what we saw was much more complicated. So in some parts of the brain, it looked like PCBs were activating the thyroid hormone receptor. So it looked like there was too much thyroid hormone, and that's bad also. In some places, it looked like thyroid hormone levels were being reduced in that part of the brain, and so it looked like it was hypothyroid. And in some parts of the brain, it looked like it made no difference. So this was, the way I put it at the time is this mosaic effect is going to create an imbalance in brain development that is going to have consequences. Now, during this period, many epidemiological studies were showing that blood levels, measures of PCB contamination in pregnant women were linked to a large number of neurological disorders in their children. So our approach from the beginning was to move away from this idea of just looking at blood levels of a hormone and start to look at what the hormone does. Mm-hmm. We're not going to see any interference if you don't look at what the hormone does.
Yes.
So that was kind of the first, we pursued that for a number of years, ultimately looking at the ability of different chemicals to interfere with thyroid hormone action in human placenta. You can't do the same kind of molecular experiments in humans that you can in animals. Placenta was something that we know is sensitive to thyroid hormone, and our I don't want to say assumption, but my bet is that what happens in the placenta is also happening in the fetus. So I think that's as close as we can get to showing that chemicals today, in the population today of pregnant women, the placenta is actually activating chemicals to be like thyroid hormone in the fetus.
Right.
And that's not going to be good.
Right. But here there are a couple of things. First of all, you've explained so well for us this effect in the placenta. But the other thing that I think many of us don't realize is you've been studying this for years. And that leads us to the next thing, and I think we have to close with this. Unfortunately, we need like 3 programs on this. And that is that you have tried to get the regulators, the agencies, to test this differently, but they keep persisting, right, with this completely outdated way of testing, which is misdirects all the time. So Why is that? Why do they hold on to this? Because we trust the regulatory agencies. So we have a big problem there. They're testing wrong, and the scientists have been trying to get at this for a long while. And then why does this persist?
There are probably many reasons. I think so. Several years ago, I was on a science advisory board for Pew Charitable Trust that was evaluating the way FDA food safety did their risk assessments. How do they function? How do they work? It's a very opaque system.
Yeah.
And I think that project went for 2 or 3 years. And during that period, a good example is I was moderating a workshop that had 5 of the main people in FDA food safety. And we were trying to figure out how FDA does, how do they do a risk assessment when there's a chemical that can come from food and other sources.
Yeah.
So you have to know where, how are people being exposed to this chemical? And the FDA people in the room simply wouldn't answer any of my questions. They were just not responding. And so I said, I don't know why you're not responding. It seems pretty clear the Pew people had developed a kind of a program with examples. And they said, well, I don't even know what you're talking about.
Oh boy, yeah.
This is the director of FDA food safety. And I said, well, Pew has come up with these examples. And he said, well, those examples aren't relevant. And I said, well, wait, you can't say that you don't know what I'm talking about and say that these examples aren't relevant.
Yeah. Right.
At a coffee break, I asked, all 5 were standing around talking, and I said, it seems like you guys are stonewalling. And he said, yeah, what do you think? These people are paid by
trust.
Yeah. So I think a big part of it is they do not want to be questioned about what they do. They don't want to be criticized. Now, they're in the hot seat. There's no doubt about it. They've got industry with big money on one side, and they've got mothers on the other side. Right. So this is a difficult place to be, but they're being paid to be there. If they didn't want to be there, they should go somewhere else.
Well, the other thing there is that you have been pointed out also is that this is big money. Then this has a tremendous effect. I'm not sure whether people realize how important lobbyists, the role of lobbies in this country and so on. So, but you tend to want the agencies to be independent and you trust that, and then that's not the case. You've sort of implied, well, more than implied, that this is big money. We've been through this with Monsanto. We've been through this with many of these industries. What can scientists do if this is going to be a continuing problem?
Well, it certainly will be a continuing problem, in large part because you can see the people in the industry and regulatory agencies going back and forth. So these are buddies, and they're working. And I think part of it comes from, at least they can defend this by saying that if we help industry, we're going to help people because there will be jobs and et cetera, et cetera. I mean, that's just a lie. That is just a lie. They're not helping anybody. These chemicals are affecting our health today, and they're affecting our children today. And everybody should be outraged that their tax dollars are going to this kind of misinformation. And it's true both for FDA food safety and EPA.
And many things.
EPA, it's really obvious now because we have a lobbyist as the administrator. But in the FDA, I think they stay under the radar. They didn't have to, the Trump administration didn't have to change people there because they were already captured by industry.
Very important. That may be true to some extent in EPA as well.
Totally. Yeah.
Before we leave, how do we compare with other countries that have regulatory agencies as well? I ask that because when it came to glyphosate, some of these agricultural chemicals, the big issue there, we've had denial, 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 protection, protection, protection here. But Europe, the EU, got on the case way ahead of us. How do other countries rank in terms of these regulations?
So I think there's two things. The first is that the European Union is far advanced compared to us. And they're actually right now, I'm part of a large group in the EU to identify better endpoints of thyroid hormone action that can be used in regulation. So they're moving on these things where in the US they're not. In fact, they're deregulating here rather than regulating. But I think it's also important to point out that health indices in the US are far below what they should be for other modern economies.
I see.
Our government is not doing us any favors.
Right.
I want to point out that when the Trump administration reduced corporate taxes, there was a lot of debate about how corporate taxes let's say in the European Union are much lower than they are here. But those industries have to pay a lot more money to make sure that their products are safe. So here, we're not getting the taxes from industry, and they don't have to pay money to make sure their products are safe.
Right.
So our government is not standing up for the people who are supposed to be kind of for, who they're working for.
Exactly. These are tremendously important points. Write a book.
One more point. I think that
yes, sir.
I think it's reasonable to say that the government should provide a platform for industry to be innovative. And I think that's important. But what's happening is that because of lobbying, all the government does is protect the market share, not the market, just the market share.
Right. It's an endangering an entire population.
Totally.
This is bad enough anyway. But you've given us such excellent information. I can't thank you enough for this.
Thank you.
We need to get more. But Dr. Zoeller, thank you so very much for giving this very important information for the general public. I hope people pay attention to it. We all feel very paralyzed right now, but maybe things can change down the line. I don't know, but you've really been a great voice for the scientific community, and thank you so much.
Thank you.